So today we're gonna start with new chapter. We're gonna go to chapter 7. We're gonna talk about a system of equations. Yep. So we have system of equations. When we have a system of equation, we're talking about a system consists of at least two equations. So for instance, we can create a system. Let me go ahead and write down the system they have here so I could use their numbers. There's 2x plus 5 plus y equal 5. And then another equation, say for instance, 3x minus 2y equal 4. Now, a system of equation, we say a solution to a given system of equation is a point that satisfies all the equations in the system. So for instance, if we take a point, say for instance, let a coordinate point 2, 1. To determine if this point is a solution of the given system, then we will just simply substitute that point. And then if it is a solution to each equation, then it is a solution to the system. So from this point, for instance, in equation number 1, if I were to put 2 for x, 1 for y, we end up with the following. 2 times 2 is 4, 4 plus 1 is 5. So 2, 1 is a solution to equation number 1. And let's check it in equation number 2. 3 times 2 is 6. 6 minus 2, 2 times 1 is 2. So 6 minus 2 is also 4. So 2, 1 is a solution to both equations in the system. Therefore, we say the system has a solution, and that solution is 2, 1. When we're talking about system of equations, let's talk a little bit first about linear equation. Linear equation represent lines. So when I have an equation, for example, 2x plus 12 or y equal 5, this represents simply some kind of line. Yeah? Doesn't matter what that line is. I'm just going to put a straight line. When we have another line with it, so those lines can intersect. Those lines can either be parallel, and those two lines can coincide one with the other. So another way, both of these lines will be just simply one point, one line. Yeah. If we look at scenario number 1, we can see that this is a point where both of these lines intersect. And we know every point on a line is a solution to that equation of the line. So if I take, for instance, this point over here, we know whatever equation we have for this line, this point is a solution to that line. So each line by itself has infinitely many solutions. However, when we put two lines together, for instance, and both of them, they meet at this point, we know then this point is a solution to the first line, and it's also solution to the second line. Therefore, it's a solution to the system. Okay? So in this case, when we have linear equation, we could have a one solution where both lines intersect. We could also have scenarios where both lines are parallel to each other. And if they are parallel to each other, that means those lines will never meet, and therefore they will have no point of intersect. Therefore, we have no solution. So this scenario, we have one solution. This scenario, we have no solution. And when we have no solution, we call the system inconsistent. We call that system inconsistent. Scenario number 3 is where we have both lines are the same, then they have infinitely many solutions. Because every point on one line is also a point on the second line. And since each line has infinitely many solutions, so both lines together have infinitely many solutions. And we call that system dependent. So this is inconsistent. And this one is dependent. So those are basic ideas of what those equations are. Now, when we look at, say, for instance, nonlinear, when we look, for instance, at nonlinear equations, nonlinear equation, we could have a parabola and a line, yes? That parabola and line can meet at several points, yes? We could have two parabolas, what have you. So basically, these belongs to linear equation. When it comes to nonlinear equation, we have to solve the solution and then determine all of this good stuff about the system. So now, looking at this particular system we have on the board, so now this system may have, this is a linear equation, this system may have one solution, may have infinitely many solutions. We've already determined there is one up there. How do I solve the system? In general, we're not going to go around and just go ahead and substitute points and see which one fits. We're going to have to find a way to solve the system. To solve a system of equation, one way is called substitution. And in substitution, what we do is we take one equation, we solve for one variable in that equation, and then we substitute that variable into the second equation and solve the second equation. Yes? After we're done solving for one variable, then we substitute back to solve for the other. So for instance, I'm supposed to solve for either x or y. Now it is a choice. You choose whichever equation you want to use and whatever variable you want to solve for. Normally, I would look for the easiest equation and the easiest variable to solve for. In this case, if I use this equation to solve for x, I'm going to divide by 3. Yes? If I use this equation to solve for y, I'm going to divide by 2. If I use this equation to solve for x, I need to divide by 2. But for this solving for y here, I don't need to do any division. Yes? So perhaps equation number 1 will be easy for me to solve for y, because all it takes is just moving the x to the other side. Yes? So taking equation number 1, so we have 2x plus y equal 5. To solve for y, we move the x to the other side. So y equal minus 2x plus 5. So this is step number 1. We used this equation to solve for y. Now my second step is I'm going to use this equation and substitute y. Every time I see y in that equation, I'm going to replace it by whatever y is. Okay? So let's go ahead and do that. So we have a 3x minus 2. Now we have a y. Instead of y, I'm going to replace it by minus 2x plus 5. So I'm going to put minus 2x plus 5 equal 4. And now we can see that this is an equation with one variable, and it's a linear, so all I have to do is isolate the variable to one side and the constant to the other side. So doing that, that will give me for 3x, let's simplify this. Minus 2 times the minus 2x is plus 4x. Minus 2 times 5 is negative 10 equal 4. So now simplifying and isolating x, those two x's can be added together to get 7x. I can bring the 10 to the other side, equal 14. So x equal 14 divided by 7, which is 2. Yeah? So this is, we got 2 already. Yes? So now, my next step is I need to solve for y. So to solve for y, we already know x equal 2. I can substitute it in any of those two equations to solve for y. Again, you can choose the equation that is easy for you to use. So I'm going to use the equation number 1. So now we have 2 times 2 plus y equal 5. So 4 plus y equal 5. So we can say y equal 1 by taking the 4 to the other side. And we can see that the solution to this system is the 0.21, and that's exactly what we checked at the beginning. Yeah? Now, how do I check my answer if it's correct? There's a lot of ways. Well, one way is to substitute the point back into those equations. And if it is correct in both equations, then it's a solution to the system. Yeah. But I don't want to keep going every time and checking both of them. Now notice, where did you substitute x to solve for y? We use this equation to substitute x to solve for y. I use this equation to check. Because I know if I did it correctly, then equation number 1 should satisfy, because that's the one I used to solve for y. But this one I didn't use, so I'm going to use this to check for as a solution. And if I put 2 for x, 1 for y, I end up with 4. Therefore, the solution is correct. Any questions? No? All right, let's move on then. Let's use another system. Says, solve the system x plus y equal 4. X minus y equals 2. And this is the system of equation. And again, we're going to go ahead and use the substitution to solve the system of equation. Okay, so I'm going to use equation 1 again. I can either solve for either x or y. It really doesn't matter. Your choice, whichever variable you want to solve for first. So this time, let's solve for x in here and substitute back in. And let's see what I get. So if I take x plus y equal 4, then x equal 4 minus y. So now, I use this equation to solve for x. I'll substitute x in this equation. Okay? So here's what we have. Instead of x, we're going to put 4 minus y equal 2. Yeah? Simplify this. We have 4 minus 2y equal 2. We can bring the 4 to the other side. Or I can bring the 2 over here and the 2y to the other side. So 4 minus 2 is 2, equal 2y, and y equal 1. Yeah? So that gives me a solution for y. To solve for x, again, we're going to go to either one of those. Notice I always go to the original one. Why? Because if I make a mistake over here and I go back over here, my mistake is going to continue with me. Yes? So I go back to the original, and I'm going to replace y by 1. Then we have x plus 1 equal 4, and x equal 3. Yes? So now we're going to go ahead and check it. Since I used the top one to solve for for x, I'm going to check it back here. So we have a 3 minus 1 equals 2. That is correct. So my solution is 3, 1. Okay. Any question? Easy enough? All right, let's do some application problem. It says a total of $12,000 is invested in 2 funds, paying 5% and 3% simple interest. Okay. So you have $12,000. So 12,000. Those $12,000 are invested in 2 accounts that pay simple interest. One account pays 5%, and one account pays 3%. Yeah? At the end of the year, it says the total annual interest from those accounts is $500. So total interest is $500. And the question is, how much you invested in each account? Question is, how much you invested in each account? So that means we need to set up a system of equation, yeah, and solve the system of equation, and then figure out the amounts, yeah? First, I'm looking for how much I invested at 5%, how much I invested at 3%. I don't know the amount, so what I'm going to do is I'm going to assume a letter for each one. Okay? So this is always step 1 in your calculation. Let x be something and they describe it so people know what it is. For instance, I'm going to say, let x be amount invested at 5%. Okay? Then let y be amount invested at, say, 3%. Yes? Okay, now to write equations, a system of equations, we need to find out the relationships between x and y. What kind of relationship do x and y have from the given? So you're given numbers. 12,000, right? You're given 500, 5%, and 3%. Let's think about those numbers for a second. What does the $12,000 represent? What are these? The 2 numbers combined, right? What are those 2 numbers? The x and y. So equation number 1, right there, right? x plus y equal 12,000. Clear? So now let's think about the other numbers. 500. What does the 500 represent? The interest from the x and y. Good. So now, how do I get the interest from the x? 5% of x. Exactly what you said, right? How do I write that? So 0.05 x. Yes? Because the x amount, whatever amount I invested at 5%, it's giving me that much interest at the end of the year. Yes? Plus, how about the interest I get from y? 3%, so that means 0.03y. Both of these interests at the end of the year must be how much? $500. Yeah. If you don't like decimal in your equation, you can just simply multiply it by a number that will remove the decimal. Every time I multiply by a number with a zero, I move the decimal once to the right. How many times do I need to move the decimal to get rid of all the decimals? 2 times? So I'm going to multiply everything by 100. If I multiply by 100, 1, 2, that's gone. 1, 2, that's gone. That's enough, right? This one doesn't have a decimal. I just multiply the number by 100. So I can rewrite this equation as 5x plus 3y equal 500 times 100, 50,000. Okay? So now we have this system of equation. Equation 1 says x plus y equal 12,000. And then equation 2 says 5x plus 3y equal 50,000. So now we can use the same techniques we've been using, a substitution method, right? And then solve the system. I can solve over here for y in terms of x. So from equation 1, we have y equal 12,000 minus x. With that said, then I can go ahead and substitute this number into the second equation. So we have 5x plus 3 times 12,000 minus 3x equal 50,000. Oh, sorry. This I'm already multiplied in my head. X, sorry. Yes? Now, let's simplify this. That's going to be 5x plus 3 times 12,000 is 36,000 minus 3x, that's where the 3x comes in, equal 50,000. Yeah? So now we can, 5x minus 3x is 2x. So 2x equal 50,000. Take away 36,000, 14,000. 2x equal 7,000. Yeah? So now x equals 7,000. We know what x is. Can I figure out what y is? Both of them are 12,000, right? So y is 5,000. Let's check that. We're going to check it into this equation, yes? Or why I want to check it into this equation? Because that's the interest equation, right? I want to see if I get interest on those, do I get $500 at the end of the year? So 5% of 7,000 is 350, yes? And 3% of 5,000 is 150, and 350 plus 150 is 500. So my answers are correct. Yeah, easy enough? All right, you say so. Okay, most of the time, when we're dealing with nonlinear system of equation, substitution is the right way to go. Most of the time, when we're dealing with non-linear system of equation, it is substitution. That's the way we go. So now, let's go ahead and take a system of equation where one of the equation is basically nonlinear. Consider the following. It says 3x squared plus 4x minus y equals 7. 2x minus y equal minus 1. Says solve a system of equation. In this particular system, did I say 1? That's a y. That's a y or 1. Yeah, that's a y. In this particular system, it's very important to know what letter you're going to look for to make life a lot easier for yourself. Yeah, you can solve for either. X and y really doesn't matter. But for instance, we have x squared and x here. Do I want to use x? Do I want to use equation 1 to solve for x? That's not going to be easy. Yes? Over here, we have a linear equation, right? I can solve for x, which is no problem. But what happened? When I go back substitute, what do I have to do? I have to square that number. Notice, we have x squared, right? Do I really want to solve for x and square it? Unless I really have to, I wouldn't want to. But if I were to solve for y, I'm just going to put whatever y is right away. Yes? And that would be good. Okay? So in this particular system, I'll probably solve for y, substitute into the equation 1, and then solve the system from there. So now we have, from here, we have a negative. If I bring y to this side, 1 to this side, we end up with 2x plus 1 equal y. Yeah? So what we did was, we took y to this side, 1 to this side, and that's what we have. So now, I'm going to go back and substitute this into equation number 1. So we have 3x squared plus 4x minus parentheses 2x plus 1 equals 7. So let's simplify this a little bit. So we have 3x squared plus 4x minus 2x minus 1 equals 7. When we're looking at a quadratic, nonlinear, we always have to put everything to one side, and the other side will be 0. Yeah? So we have 3x squared, and 4x minus 2x is plus 2x minus 1, and minus 7 minus 8 equals 0. Yes? So now we need to factor this. Okay? So how do I factor this? First, I don't have a common factor, right? Which is good. So here's what I'm going to do. I'm going to take A multiplied by C, right? So 3 times the negative 8 is negative 24. And then B is, so let me write it down over here. AC, and B is 2. Now we need to look for two numbers. When we multiply them, we get negative 24. And when we add them, we get 2. Okay? So let's take a look at those numbers. Worst case scenario. Look at all the numbers you multiply, you get 24 first. We know one of those numbers has to be negative. We know the sum is positive, so the bigger number is positive. So to get 24, 24 times 1, the 1 has to be negative, yeah? Those don't give me 2. Next, 12 and negative 2. Do I get a 2 when I put them together? So let's go to the next step. 8, negative 3. No? All right. 6, negative 4. Are these my numbers? Yes. So let's go ahead and do that. Now, because I used AC over here, what I need to do to those numbers is I'm going to divide both of them by 2. Okay? So I'm going to put a 2 over here, 2 over here. Whether I can divide it or not, it really doesn't matter. Okay, now what do I get? 3 over 1. And negative 2 over 1. Yes? Did I get a 6 and 4? Oh, this is just 3 over here. Sorry about that. We're dividing by A. I said A and I put B. Okay? So 6 over 3 and negative 4 over 3. Now notice I can divide this, and that's going to be 2 over 1. Yeah? Now how do I write my factors? Okay, to write your factors. And the second one, negative 4 over 3. Here we go. From the first one, that is goes with X. That number goes with X. That number is a constant. So how many X do I have? 1 X. So that's X plus 2. Okay? Now, the second number. That's what goes with X. That is a constant. So what do I have on the second one? 3X minus 4. Okay? Let's see. X times 3X is your 3X squared. Yes? And 2 times negative 4 is your negative 8. And then we have 6X minus 4X is 2X. So now this is equal to 0. So what is X? So X equal to minus 2. X equal negative 2. And X equal 4/3. Okay. So now we already know what X is. For this equation, we get 2 values. So all I have to do is substitute each value into the equation and figure out what Y is. Yeah. Now, where do I want to substitute back? This is the easier one, right? So I'm going to substitute back over here. So we have 2 times, first X is negative 2 minus y equal negative 1. And then we have negative 4 minus y equal negative 1. So y equal negative 3. For the second one, we have 4/3. I'm going to use this one. Y equal 8/3 plus 1, which is 11/3. Okay. So now we have 2 points. First one is negative 2. When I put negative 2, what value of y we get? And then for the second one, we have 4/3, comma, 11/3. Okay? Do another one like that? Yes? Oh, you already got it. We don't charge money if you speak up. Do another one. Let's see if they have another one. Okay, another one. 2x minus y equal negative 3. 2x squared plus 4x minus y squared equals 0. Okay? So now, again, we have two equations. We have a nonlinear system. Again, I can solve for x, I can solve for y, whichever one I want to do. Yes? Now, on top, it's easy to solve for either one, or x or y. Now, I'm not worried about that. Now, what I worry about, which one is going to give me less work to do. In here, both of them looks like I have to square them, right? So unfortunately, I need to square one of them. But for the x, I need to square it, and I also need to do what? To do another substitution. So I have to do the two substitution for x. So I'm just going to solve for y, and then square that. Yes? So let's take equation 1. So y equal 2x plus 3. Yeah? And I know I'm going to square that, so I might as well go ahead and get the square right away. What's the square of that? So y squared equal 2x plus 3, 2x plus 3. Okay? If I square this, we end up with 4x squared plus 12x plus 9. You can use the formula and then write it down. Yes? So 2x times 2x is your 4x. That's a 6x plus 6x give me 12x. 3 times 3 is 9. So now I'm going to take y squared, substitute it here. We're going to take y squared and we're going to substitute here. So what do I have? So we have 2x squared plus 4x minus 4x squared plus 12x plus 9. That's equal to 0. Let's remove the parentheses. So we have 2x squared plus 4x minus 4x squared minus 12x minus 9 equals 0. Let's simplify that. 2x squared minus 4x squared is negative 2x squared, 4x minus 12x minus 8x, and then we have a minus 9 equals 0. Yeah? I don't like the negatives, do you? I just multiply the whole equation by a negative. So what do we get? 2x squared plus 8x plus 9 equals 0. Yeah? Okay, now, we need to see if we can basically work this out and solve. Yes? So first I want to see if I can factor it first. Yes? Let's see if I can factor it. To factor it, I'm going to multiply 2 times 9, which is 18. We have an 8. So I need to look for two numbers. I multiply them, I get 18. Yes? When I add them up, I get 8. Let's see. So we have 18 times 1. We have 9 times 2. Yes? We have 6 times 3. Anything else? Only thing, if there is, it'll be with a 4 and 5. Can't find it. Any of these give me 8 when I add them? No? Then I can factor. Do something else. What else do I do? Well, the next step is use quadratic equations. Using quadratic equation, we can say x equal minus b plus or minus square root b squared minus 4ac over 2a. Yes? Let's figure out this portion. So when I substitute, I just don't have to rewrite it all together. Yes? So b squared minus 4ac equal, b squared is 8 squared, that's 64, yes? Minus 4 times 2 times 9. 64 minus 72, and that should give me 8, negative 8. Yes? Now notice, I'm getting a negative under the square root. Yes? Is that a real number? Not a real number. No solution. It's not a real number, therefore it is no solution. We're clear on that? Yes? Okay. Sometimes we could, for instance, solve the system by graphing, which is not really the recommended way. But if you're only looking for an approximation of the answers, you can go ahead and do graphing. Okay? So for instance, wherever two graphs meet, that's basically where your solution is. So let's take a look at, say for instance, y equal ln of x and then x plus y equal 1 to see if we can solve the system by graphing. To do that, we just graph both equations. To do that, we just graph both equations. The first equation says y equal ln of x. If you remember that, we said ln of x passes by the point 1. Yeah? So then, that's how the equation look like. Okay? The second equation, it's a linear equation, right? And a linear equation, when x is 0, y is 1. And when y is 0, x is 1. The intersection point, that's your solution. What is that? The x value is x equal how much? 1, y equal 0, 1, 0 for that. Now, you're not lucky every time. Okay? So this is basically an idea on how to do that. Okay? In business, when we're doing business, there is a point we call break-even point in business. A break-even point is a point at which your revenue and your cost are the same. Another way, you didn't lose money, but you didn't make no money. Yes? And this is where you start getting happy. Because after that, whatever items you sell, then that will be a profit. Okay? And when we're talking about cost, we're talking about two things in cost. One is called fixed cost, and one is called marginal cost, or cost per unit. For instance, if you want to make, say, you want to open a business, before you even think about what items you want to bring into the business, you're going to have to put you have to have a place for business, right? You're going to have to buy equipment. You may have to buy machines, whatever. All of these are called fixed costs. This is the cost that you have to pay in front. Okay? After that, you start doing your business, whatever it is you want to do. During the pandemic, a lot of people start making masks. Yes? Before they start making masks, what do they need? They need a sewing machine, perhaps. Yes? So they have to do the investment. The first fixed cost for this business was to buy the sewing machine. Whatever it costs, $300, $400, $500, doesn't really matter. Now, variable cost is the cost that you pay for material to make each mask. Okay? So each mask may cost you, let's say, 2 cents, 3 cents, 5 cents, whatever. So these are your costs. And then your revenue will be how much you're selling each one times however many you sold. So basically, when you do business, then you have to have a certain amount of items sold to break even. Because now, if you're making those masks, you have to sell enough masks to recover the cost of the mask plus the cost of the sewing machine that you bought. After that, it will be just simply a profit. Okay? So let's do some problem like that. Let's see what this problem says. Says, a shoe company invests $300,000 in equipment to produce a new line of athletic wear. So this company invested $300,000 to produce a new athletic wear. It says each pair cost $15 to produce. So to produce a pair of shoes, you pay, or the company cost would be $15 per shoe, per pair of shoes. Yes? Now, it says the shoes are sold at $70 each. Yes? So sold at $70 each. So now you're the mathematician or the person in charge of this. It says, how many pairs of shoes must the company sell to break even? Yes? So we're looking for the number of shoes that the company needs to sell to break even. Yes? So now we say, at break even, cost must equal to revenue. So this is the big idea. So the cost that we did has to equal to revenue. Yes? So we need to create a function for the cost. We need to create a function for the revenue. Yes? And then put them equal to each other and see if we can solve that. So let X equal number of shoes. So we need to create a variable to represent the number of shoes that we have. Yes? So what is the cost function? C of X equal. So what is the cost function? What is the company pay, or what is the company paying to make those shoes? $15 per shoes. So if they want to produce X amount of shoes, how much they're going to pay? 15X. Is that all the cost the company paid? Plus what? Plus the 300,000 initial cost. Yes? So this is what we call your fixed cost. This is what you cost to start, and this is your variable cost. Why is variable cost? Because it depends on how many shoes you make, and it changes, right? You make one shoe, it costs you $15. So now notice, if the company just made one pair of shoes, how much is that pair cost? $300,015. Yes? That's why when you make a little of things, it costs a lot of money. Yeah? Why? Because this is the initial cost what you put. However, when you make a lot of them, the initial cost is being distributed throughout those shoes, right? And therefore, it becomes negligence at the with a huge quantities you make per shoes, not as a total per shoe. Yep. Okay, so now we figured out what the cost. What is the revenue of the company? Revenue is not a profit. Revenue is how much money you're collecting or coming into your pocket. No. Right. 70X. Why 70X? Because now your costs are gone, right? Now you're starting to sell it. How much money coming into your pocket? Coming into your pocket is $70 for every shoe you sell, right? So that's 70X. Clear? So now, break even means what? Break even means C of X equal R of X. That's my break even point. Yeah. So now I can take this equation, set it equal to this equation, and solve it. So what is the cost function? So 15X plus 300,000 equal 70X. Correct? So to solve this equation, we take the 15 to the other side. So we end up with 300,000 equal 55x, then x equal 300,000, divide that by 55, and what's the number? 54, 55. So that means the company must sell 5,455 pair of shoes in order to recover its cost that it did. Now, after they do that, then each shoe they sell will be a profit of $55. Okay? After they recover their cost. Provided whatever equipment they bought with those $300,000 is still working properly. Yeah? Because after that, then you start, when it's like your car. When you buy your car from the company, the first probably 4 or 5 years, you have less maintenance on it. Yeah? Only doing oil change and what have you. After that, or after a period of time, what happens? You can't just say it's just a little bit maintenance. No, stuff starts breaking down. So this breakdown, you have to replace it, and so on, and therefore it becomes costly. Yes? Any questions? No? All right. So now we talked about one method called substitution method. Okay? Another method in solving system of equation is called elimination method. Elimination or addition method, depending on the book you're reading. And we'll talk about why it is called that. So let's go back and take a system of equation. Say, for instance, let's do one we just did back before I get to the other one so I can explain the idea. Okay, consider x plus y equal 4. And we also said x minus y equal 2. Yeah. When we solve this, we did substitution, where we looked for one variable in terms of the other, yeah, and then substitute it, and then find the value, back substitute to find the other value. Yes? In this particular sequence, let me give you, if I say x equals 5, yeah, and then I tell you y equals, say, 4, yeah, what I could say also, if I were to add this side together and this side together, I can tell you then x plus y would be 9. Correct? So that's the idea behind elimination method, where we're going to add both sides of the equation to each other. But in order to do that, we want to add it to a way we benefit us. How? We want to add it in such a way that when I put them together, one of the variable is definitely gone. Okay. So that's why we eliminate one variable. That's the basis from elimination method. Some people call it addition. Why? Because simply what we're doing is, in order to eliminate it, we add them. Okay. So to do that, it'd be wise to have those equations in the same format. In the same format, meaning that if you have x, y equal a number, make sure all the equations are in that. X, y equal a number. If you have x, y, a number equals 0, try to have all the equations in that fashion. Yeah? So my aim is to have two coefficients of one variable from different equation to be the opposite of each other. So if one is 1, the other one I want it to be in -1. Why? So when I add them, they cancel out. If one is a 5, I want the other one to be -5. If I look at those equations, I can see right away that the top equation has a +1 for y, right? The bottom equation has a -1 for y. So that means they are the opposite of each other. So I don't have to do much work. All I do is I can add those two equations and get rid of y. Let's see what we can do. X plus x is 2x. Y minus y is 0. 4 plus 2 is 6. So now we know 2x equals 6. So x equals 3. Yeah? So we figured out what x is right away. So now we can go back substitute to figure out what y is. So we back substitute 3 plus y equal 4, y equal 1. Okay? So that is the elimination method. In some cases, the elimination method is easy. In some cases, maybe substitution method is easy. So you have to decide on that on your own. Yes? Okay, this is a simple example just to illustrate what that method is about. Yes? Let's go ahead to do some equations where some work needs to be done to get there. Okay? Consider, for instance, 3x plus 2y equal 4. And 5x minus 2, oh, this is also easy one. 5x minus 2y equal 12. Huh? Okay, I'll look at the example 2. Not that much, but anyway, let's do example 2. This one we just did that, right? We just 2y minus 2y, add them together, they're gone. Let's do another one. Let's take a look at 2x minus 4y equal minus 7, and then 5x plus y equal 1. Well, negative. So we need to use elimination method to solve this system. Again, the idea behind the elimination method is we want to look at the coefficients of x and y and try to make them, at least one of them, have the coefficients opposite each other. Yes? So there are things I want to look for. First thing I want to look for is if they're not the same and opposite, then I want to make them. The way to make them is I want to try the easiest way to do that. And the easiest way to do that is eliminate the variable that has a coefficient of 1. Because that when you have a 1, you can manipulate that and make it whatever you want by simply multiply the whole equation by a certain number. Yes? So this is a 2x. This is a 5x. I need to multiply maybe twice to get them to be the same number. Yes? But here we have a -4. Here we have a 1. So I can do one multiplication to make them the coefficient the opposite of each other. Yes? Okay. My intention is to make this a plus 4. So how do I do that? I can multiply the whole equation by 4. Yes? So let's go ahead and do this. So I'm going to put 4 over here, indicating that's what I'm going to do to this equation. Equation 1 is the same. So 2x minus 4y equal minus 7. And then when you multiply by 4, you have to multiply the whole equation. So we have 20x plus 4y equal negative 1. Done. So far, so good. So now, if I were to put them together, your 4y cancels out because one is positive, one is negative. 2x plus 20x is 22x equal negative 11. Then x equal minus 1/2. Yes? So now we already figured out what x is. I'm going to figure out what y is. Again, when you substitute, you really want to try to substitute it where it's easier to work with. Now, if I were to substitute here, I'll get 5 over 2 when I multiply by 1/2. That's going to be a fraction. But if I were to substitute here, what happens? 2 times 1/2, the 2 cancels out, we're left with 1. So I'd rather substitute on the top one. So to substitute, there we have 2 times negative 1/2 minus 4y equal minus 7. So negative 1 minus 4y equal minus 7. So negative 4y equal minus 6. So y equal 6 over 4 is 3/2. Yes? Any question? So we can do one more quick example and be done with that. All right, let's take this one. So we have 5x plus 3y equal 9. Two x minus 4y equal 14. In this particular problem is, unfortunately, we don't have a coefficient of 1. I don't have a coefficient of any that I can multiply 1 to get to the other. For instance, I have a 2 here. I don't have a nice number to multiply by 2 to get 5, right? I don't have a nice number to multiply 3 by to get 4. How do I do it with this? The best way to deal with this is, first, we do have a positive or a negative, so that will eliminate multiplying by a negative number, right? So I'm going to try to eliminate the y. To eliminate the y properly, you multiply the top equation by this coefficient and the bottom equation by that coefficient. So here's what we have. Then I multiply by 4 and 3. So now we have 4 times 5 is 20x plus 12y equal 36. And then we have 6x minus 12y equal 42. Now we can add them. When we add them, we end up with 26x equal 78. Yeah? And then x equal 78 over 26, 3. Now to figure out what y is, just substitute x3 in any of the equation and solve for y. So we have 5 times 3 plus 3y equal 9. 15 plus 3y equal 9. 3y equal negative 6. Y equal negative 2. Now notice, again, I use this equation to solve for y. I can use this equation to check. So 2 times 3 is 6, minus 4 times a negative 2 is 8. So 6 plus 8 is 14. So the answer is 3, negative 2. Yeah. Any questions? No? All right. If you guys don't have a question, then that's it for today. I'll see you back here on Thursday, God willing. And again, pay attention to whatever sign you'll probably see, hopefully, between today and tomorrow, you will see the test or at least the review available for you to start working.